Okay, welcome to the Demography Today lecture series, sponsored by the BBA Foundation, the Horizon 2020 Lompoc project, and the Spanish National Research Council. And we have the pleasure to have today here Giambatista Salinari. He's a research scientist in demography at the University of Sassari in Sardinia, Italy, where he teaches statistics and forecasting methods. He previously worked at the Department of Statistics of Florence and at the European University Institute of Florence. His research interests include topics like contemporary migration, the analysis of demographic transition, and family income dynamics. In recent years, his research interest has turned to the analysis of aging in human populations and to biodemography. In a recent publication on demography, he proposed a statistical technique to identify the onset of demographic aging in human cohorts. He also tackled the problem of statistically testing competing theories on aging in three research articles in Population, International Journal of Population Studies, and Biodemography and Social Biology. So welcome, Giambatista, and as usual, we leave the speakers between 45 minutes to 1 hour, and then we open the floor for questions.
Today I present some results and some reflections on the Sardinian centenarians. So, let's see the beginning of the story. This story begins in 1999 with a study conducted by Diana on the population of the Sardinian centenarians. And the two main outcomes of this study were that the prevalence of centenarians in Sardinia was found to be very high. And then, for perhaps the most surprising outcome, is that the sex ratio, that means the female to male ratio, it is also called the femininity ratio, was found to be very low, about 2 female centenarians per 1 male centenarians. The normal value in the European countries ranges between 4 and 8 female centenarians per 1 male centenarians. These results were considered so strange that at the beginning there were some criticism, and well, there was the doubt that the results were not completely reliable. For this reason, an international task was sent to Sardinia in order to check the reliability of these results, and after a few years, Michel Poulain confirmed that these results were good. So actually, the population of the Sardinian centenarians presents some strange characteristics, and well, the aim of this presentation is to try to give a sort of first explanation for these strange results. In 2004, Poulain published a research work on longevity in Sardinia, and he was able, with other colleagues of course, and he was able to identify an area which after this study was called the blue zone, where longevity, well, the prevalence of centenarian was particularly high, and where the sex ratio was surprisingly low. In this area, the femininity ratio has been found to be of 1, so 1 female centenarian per 1 male centenarians. This area is characterized by a shepherd economy, and it's a mountain area. So, in this presentation, I will show you the results from 2 articles. The first one has been produced in collaboration with Gabriele Ruju, which is a colleague of mine at the University of Sassari. And the results of this study has been published on Genus last year. And then, well, this first article, it's oriented to give an explanation of why in Sardinia there is this high prevalence of centenarians. The second article, which has not been published yet, we have just finished to write the article, is a collaboration with Cristina Giuliani of the University of Bologna, Marco Breschi of the University of Sassari, Claudio Franceschi of the University of Bologna, and Gustavo De Santis of the University of Florence. The aim of this second research work is to find an explanation for the second strange finding for the population of the Sardinian centenarians, that is the very low sex ratio in this population. So I start with the first problem, the evolution of the rate of aging in Sardinia. So first of all, I would like to give you some basic information about the chronology of the most important events in the Sardinian population history. And I begin with the mortality transition in Sardinia. So in 1887, we know it's the first investigation, it's first data that we have on this population, it's the first information on by-cause mortality. And what we know for 1887 is that about 10% of the deaths in Sardinia were produced by malaria. And this is a very high proportion. It was the first cause of death in Sardinia. But this fact is even more surprising if we consider that malariologists, people specialized in the study of malaria, assume that the indirect effect of malaria, so the death caused indirectly by malaria, are about 3 times the death produced by malaria. So if we follow this rule of thumb, we found that probably in Sardinia, at the end of the 19th century, about 1 death out of 3 were caused directly or indirectly by malaria. A very important moment in the evolution of the population, the Sardinian population history, is the 1900 date, when what is called in Italian the legge of Chinino di Stato, when this law of the Italian state was introduced in Sardinia, and this law forced all municipalities and landowners to bear the local cost for the quinine prophylaxis. And we can see here we have the evolution of by-cause mortality, the mortality produced by malaria from the 1887 onward, and we see that from the introduction of the legge on Chinino di Stato, there is a sudden drop in malaria mortality. Then here we have the effect of the First World War, when the prophylaxis with the quinine was interrupted, and then again. So the introduction of quinine, the mass diffusion of quinine in the Sardinian population had a really huge effect, and we will see, we will consider the introduction of quinine as an intervention, and we will use this intervention to see what are the causes which led to the emergence of the centenarian population in Sardinia. We can also see that the introduction of quinine perhaps had some important effects also on other diseases like diphtheria, erysipelas, meningitis, pleurisy, the typhoid fever, etc. Malaria mortality for us is important. The main feature of malaria is to establish a long-run equilibrium with the host, and this is a characteristic of very old diseases, and malaria, together with tuberculosis, is probably one of the oldest diseases for the human species. After the initial stage of infection, during which the risk of dying is higher, the individual suffers periodical febrile reaction and that lasts for 3 or 4 days, depending on the species of Plasmodium. Those malaria periodically stress, and this is really one of the central points in my reflection on Sardinia, the immune system for a long period of time, which, according to the theory of inflammation, should result in a faster aging. So we can hypothesize, and we will see this better in the next slide, that the introduction of quinine may have reduced the rate of aging of the cohorts, of the Sardinian cohorts. Of course, the law on quinine is not the only intervention that we have during this period. Early measures for improving hygiene condition were introduced during the cholera epidemic in 84-85, and this is a very simple hygienic measure: washing hands, boil water, substantially produce the disappearance of cholera and of typhoid fever from the epidemiological Italian landscape. These measures were probably responsible for the reduction of typhoid fever. Then in 1888 we have the introduction of the smallpox vaccine, and then again the serum against diphtheria and tetanus. So we can say that the last decade of the 19th century and the beginning of the 20th century is really a turning point in the epidemiological history of Sardinia. Okay, after having considered the evolution of mortality and epidemiological transition, I focus briefly on the evolution of nutrition in Sardinia. This is another important, here Sardinia presents some peculiarities, important peculiarities. Well, the first peculiarity is that during the 1930s, Sardinia was studied by nutritionists interested in determining the differing nutritional levels of the Italian regions. And in this investigation, consumption was broken down into carbohydrates, proteins, and fats by methods that resemble modern nutritional studies. So we are lucky, I think, from this point of view, because we have good information on the nutritional status of the population. Here I show there are many different surveys that have been carried out in Sardinia, but for us, I think the most important is the one carried out by Peretti, because the analysis of Peretti cover the area of the province of Nuoro, which is exactly the blue zone that I've showed you at the beginning of the presentation, and it is the zone, the area of Sardinia where the prevalence of centenarians have been found to be the highest. So the diet, according to Peretti research, the diet followed by the peasant population was practically vegetarian. The daily caloric consumption amounted to about 2,600 to 2,800 kilocalories per day. I think it's more important for us that the adult male peasant population had an average height of 157 centimeters and an average weight of 52-53 kilograms. These two information allow us to calculate the body mass index for this population, and what we found is a number 21, which is a sort of magic number, because in a domain of biogerontology, which is called which have produced what is known as the calorie restriction experiment. This number, the threshold of 21 kilogram per square meter, have been found as the threshold value under which a significant increase in longevity should be expected. So this population actually has, in the 1930s, from a nutritional point of view, a good nutritional condition for longevity. The evolution of heights of statures allows to have an idea about the chronology of the nutrition transition in Sardinia. The nutrition transition is, well, the transition from a low to a high calorie consumption. And, well, from the analysis of the stature, this is Sardinia, and this is Alghero, is a little town in Sardinia. Well, what we know is that Sardinia was the Italian region with the lowest average height. The average of Sardinian cohorts born between 1861 and 1927 ranged between 160 and 162 centimeter, without any substantial upward trend in the time series. And this is another peculiarity of the Sardinian population, because if we compare the evolution of heights in Sardinia with the evolution of heights in Italy, we see that in Italy a trend exists, is an upward trend. So we can infer from that probably at least until the 1930s the Sardinian population has not changed its nutritional regime. But according to the literature on the nutrition transition in Sardinia, well, the most important date is probably in the 1950s. So probably the best well, the best conjecture on when the nutrition transition began in Sardinia is the 1950s. Okay, let's have now a sort of synthesis on these different events in the population, the Sardinian population history. So we have seen, first of all, the epidemiological transition, which probably began in the last decades of the 19th century. Then we have the introduction in 1900 of the quinine in the Sardinian population. Well, let's notice that this area is this temporal period is the period when most of the centenarians, which will be investigated by the IANA in 1997, were born. Then we have from 1900 and 1950s, well, a sort of condition of stationarity. We have a low disease burden because most of the disease in the Sardinian epidemiological landscape have been reduced by the arrival of the epidemiological transition, but we do not have a parallel rise in the nutritional level. Okay? In general, I would say the typical pattern is that to see more or less the epidemiological transition, the nutrition transition happening at the same moment. This is not the case of Sardinia. In Sardinia, between the onset of the epidemiological transition and the onset of the nutrition transition, there is a period of time of 50 years, which is a long period of time. So during this epoch of 60, 50 years, we have a period characterized by a lower disease burden and a low nutrition. And both these characteristics are associated to slower rate of aging, according to the main theory of aging. So let's see this theory of aging. So we present basically three different hypotheses. We started with the constant senescence hypothesis. This hypothesis comes from demography. This hypothesis has been proposed by Vaupel in an article published on Nature in 2010. And well, the idea of Vaupel is that the rate of aging cannot change over time or in different populations. It's a sort of a biological constant. For Vaupel, the rate of aging is it's the slope of the individual mortality hazard function. Okay. So according to Vopel theory, nothing can change the rate of aging in a population. Okay, this is the first theory. A second theory, a second paradigm used to explain aging is the inflammaging theory. This theory has been proposed by Claudio Franceschi, and the idea is that those who experience high exposure to antigenic load, especially in their infancy, will also be characterized by a more rapid aging. Okay, so here I've tried to represent with the graph the idea of inflammaging. The idea is that if we consider low disease burden, the slope of the individual hazard function is smaller. Instead, for those which have been exposed to a high antigenic load, the slope, the rate of aging, it's higher. Okay. The third theory is that of calorie restriction experiments. Most experiments confirm, which have been generally conducted on animal model, which means mice, rats, etc. But there are also some experiments on humans. Most of the experiments confirm that the treatment group enjoy a 30 to 60% gain both in average lifespan and maximum lifespan. So there is a very important effect of low nutrition on lifespan, and I've tried to represent this fact here. We have the red line represents those with a high nutrition, and here the slope of the individual mortality hazard function is very steep. Instead, in the blue line, I represent people with a low caloric intake, which is associated with a lower rate of aging. Although it is important, there is also an effect on initial mortality. Higher caloric intake produce a benefit in terms of the initial mortality. So, the idea, the analysis that I present you today is based on the reconstitution of the life tables of the Sardinian population, the cohorts life table for the cohorts from 1866 to 1908. And so we reconstructed the life tables, and we consider this life table at age 80 plus. So we observed people born here when they are in the 80 plus age bracket. And for these people, we have estimated the rate of aging. And what we are interested to observe if there is a difference in the cohorts with respect to their rate of aging. In particular, we are interested to know if the cohorts which have been less exposed to the epidemiological transition and which knows the introduction of quinine only when they were in their early adulthood, experience a different fate, a different rate of aging with respect to the cohorts born during the onset of the epidemiological transition, that is here, and in particularly after the introduction of quinine. So we want to see if the epidemiological transition or the introduction of quinine had an effect on the rate of aging of these cohorts. So measuring the rate of aging is problematic. Is not something easy to do. Here we estimate the rate of aging by taking into account selection, which is probably the most important problem that we have to face when we want to measure this parameter. So cohorts are heterogeneous, and some individuals are more resilient than others. So here we have the individuals, the dashed lines indicates the individual hazard function. So here we have a more robust individual, here we have a frail individual. And because the more frail tend to die at younger ages, survivors to older ages tend to have favorable health endowments and healthy lifestyles. As a result, the aggregate cohort force of mortality increase more slowly than the individual force of mortality, and I've tried to represent this fact with the black solid line, which represents the aggregate force of mortality, the aggregate hazard function for the entire cohort. And so here you can see that the slope of this hazard rate, this hazard function is smaller than with respect to the individual hazard rates. So to take into account this problem, we use to estimate the rate of aging a classical model in biodemography, which is the Gamma-Gompertz model. The Gamma-Gompertz model is based on three main assumptions. The baseline hazard function is supposed to be a Gompertz model, so the individual hazard function is supposed to be a Gompertz function. Frailty is assumed to be gamma distributed, and frailty is assumed to affect the baseline hazard function in a multiplicative way. From these three hypotheses, we can derive the Gamma-Gompertz model, where the aggregate force of mortality is supposed to be equal to a first parameter, which gauge the log initial mortality of the cohort, the rate of aging, which multiply x the age, and then a last term, which take into account the process of deceleration in the hazard function produced by selection, and where the parameter gamma gauge the variability of frailty inside the cohort. So here we have the first results of this analysis, our analysis. Here we focus on the first parameter, alpha, the initial mortality. So it's only a way to describe the evolution of mortality in Sardinia at exactly 80 years of age. And well, you can see that in any case there is an important effect of the introduction of quinine on the initial mortality. So Sardinian cohorts experience at the beginning of the period under observation higher mortality than the Italian cohorts, especially the males one. This is, however, at the end of the period, the situation apparently reverted, with Sardinian cohorts presenting lower initial mortality than their Italian equivalents. Okay, this is the central part of my analysis. Here the graph represents the evolution of the different cohorts that we are investigating, the rate of aging. And well, there is a comparison always with the Italian case. Well, the first thing that it can be seen is that before the introduction of quinine in Sardinia, the rate of aging, both for females and for males, was much more higher with respect to Italy. And with respect to what we know about the rate of aging of other populations. This is consistent with the inflammaging theory, because as we have seen, malaria was a very important disease in Sardinia, and this disease periodically stressed the immune system. So we can expect, according to this theory, a faster aging in Sardinia with respect to other area of the country or of Europe. With the introduction of quinine, we have a dramatic fall in the rate of aging, and interestingly, here there are two elements which deserve attention. The first one is that in the case of females, the decline in the rate of aging is less important than in the case of male. For males, as you can see, the rate of aging observed at the beginning of the 20th century, of the cohorts born in the 20th century in Sardinia, are significantly below what we can for Italy. Okay. So these are the synthesis of the first part of the work. Before the epidemiological transition, Sardinia had a much higher rate of aging than Italy. In almost perfect coincidence with the onset of the epidemiological transition, a dramatic fall in the rate of aging occurred. The male population took more advantage from the mass diffusion of quinine prophylaxis. These results are overall consistent with the inflammation theory of aging and calorie restriction experiments, but why the introduction of quinine had only a partial effect on females? This is something that we are not able to explain with the data that we have considered until now. So here there is the second section of my presentation, where we try an initial answer, to give an initial answer to the question of why females perform worse than males in this phase. Okay, in reality, an answer to this question has already been furnished by Passarino in 2001, Passarino and colleagues. And they try to give an answer to this problem with this map. This map is a presentation of the femininity ratio, the female to male ratio in the centenarian population according to the different Italian region. And how, as you can see, there is a clear differentiation between what happened in the north of Italy and what happened in the south of Italy and in Sardinia. Okay, so in the north of Italy, in general, the femininity ratio is very high, is 6, 7, 8 female centenarian per male centenarians, while in the southern part of Italy, the femininity ratio is quite low, 3, 2, and in case of certain area of Sardinia, also 1. Well, in Passarino analysis, Passarino and colleagues analysis, they try to put these results they try to correlate these results with the information on the genetic structure of the Italian population, in particular of the characteristics of the Y chromosome. And what they found is that the match was pretty good. Let's say the genetic structure of the Italian population could explain at around 30% of the variability observed in the femininity ratio. So perhaps genetics here has something to say. In reality, what we think is that genetic factors cannot account for all the phenomenon. And this basically for one reason, because if we consider the evolution of the femininity ratio, the analysis of Passarino and colleagues in 2001 was a cross-section, and all the data were considered at a given moment, 2001. What we did here is to examine the evolution of the femininity ratio in Italy from 1970 to 2010 using information from the census. And what we found is that in many cases, there is a temporal evolution, a temporal increase in the femininity ratio. And a strong increase in the femininity ratio can be observed especially in the northern part of Italy. So, since we have observed this evolution, which is also confirmed by a study which are from Robin and others, well, it is difficult to explain this temporal evolution in the femininity ratio with a variation in the genetic structure of the Italian population, because we know that genetics evolve on a temporal scale which are much slower than the one observed here. So this suggests that other non-genetic factors may also play a role in this process. In reality, we repeat the same analysis at the European level. Here we use the data from the human mortality database, and the analysis this time is performed by cohorts. And what we found is basically the same result that we found for Italy. There is an evolution from at the beginning of the story. The femininity ratio is about 1.52. At the end of the story is about 7, 8. So it's a dramatic change. This dramatic change, this extremely important evolution in the femininity ratio at older ages have been also identified by Beltran Sanchez and colleagues in an article of 2015. And what is important in this article is that they found a moment in the history of these populations when this process began, and this moment is the last decade of the 19th century and the beginning of the 20th century. This is the crucial moment. Well, it is also interesting to see that France, in this respect, constitutes a sort of exception, because at the beginning of the period considered here, you can see that the femininity ratio is already quite high, quite elevated. And, well, what we know about France is that it's probably the first country to begin the process of fertility transition, and this may suggest, consider a first suggestion that fertility and the fertility transition may have something to say about the sex ratio at older ages. So, let's come back to the map presented by Passarino and colleagues in 2001. Well, the important fact here is that, as we saw, the femininity ratio is different between the north and the south of Italy. And what we know about the north and the south of Italy is that the timing of the demographic transition, in particular of the fertility transition, is dramatically different. In the northern region of Italy, we have an early onset of the fertility transition, which dates back around the end of the 19th century. Instead, in most of the southern region of Italy, the fertility transition began around the 1950s. So there is a difference, a temporal difference of almost 50 years. So a possible conjecture, a possible hypothesis is that the different sex ratio observed at older ages among centenarians may be related to this timing of the fertility transition. Okay, let's consider now the theory through which the existence of sex difference in longevity has been explained, and we have two family of explanation. The first one is the biologic family, and here we have sex chromosome. This is the idea proposed by Passarino. Sex hormone, testosterone. For instance, Virginia Zarulli has recently tried to explain the emergence of the sex difference in longevity through through sex hormones. Or there is the theory of mitochondrial DNA. Then there is the family of behavioral explanation. So, of course, the smoking pandemics has something to do with the emergence of this gender gap at older ages, because we know that in these cohorts, generally, smoking was more diffused among men than among women. Another theory is, well, here about the smoking pandemics, we know, thanks to the study of Preston and Wang and Bentley and Sacher, that about 30% of the evolution in the femininity ratio can be explained by the smoking. Then it has been hypothesized that obesity pandemics has something to do with the increase of the femininity ratio, but this hypothesis has been proposed by Beltran Sanchez, but we don't really have, to the best of my knowledge, an empirical study which verified this point. And then we have a last theory, the fertility transition, which was studied in the case of the Utah population by Bolund in 2016. And, well, according to the data that I've shown you, we think that this is the theory which better match our empirical data on Italy. So, women post-reproductive longevity advantage is largely a recent phenomenon in human history. This seems to reduce the strength of biologic explanation, and among the behavioral explanations, the one based on the fertility transition seems to better match the Italian data. So I'll try to show you a verification, a test of this hypothesis. So basically, we consider 8 cohorts born in Italy, in 16 different Italian administrative regions in the Italian provincia, and for each regions. For each region and each cohort, we collected data on cohort fertility, the probability of survival, the femininity ratio at various post-reproductive ages, and the proportion of ever married women. And we try with this data to test the hypothesis if the fertility decline can be seen as the responsible for the emergence of the a higher femininity ratio. So here I show you rapidly how we reconstituted for each cohort its demographic history. So I consider here the cohort born in 1892-97. When the cohort is in the 25-29 age bracket, we found an information from the European Fertility Project on cross-sectional fertility. Then at 55-59 years, we collected information on the femininity ratio and on the proportion of never married women. Then we have a new information on cohort fertility, and then until 95-99 years, we were able to collect other information on the femininity ratio and the proportion of never married women. Okay. So here, briefly, we use two different indicators for fertility. One coming from the survey, from historical surveys on fertility in Italy, the others from the European Fertility Project. Here what I want to show you is that the association between these two indicators is very elevated, and so we can use interchangeably both indicators for our analysis, and these give us some advantage. Okay, here is the main result of our analysis. So the basic idea is that the sex ratio Rx given by the number of female of age X divided the number of male of age X reflects the entire evolution of male and female mortality and migration from conception to age X. So we have to control all the effect produced by migration, maternal mortality, the mortality hump for males, etc. To do that, we use an index that we called the relative female survival, RFS, which is given by the femininity ratio at age X. Here age is greater than 59 years, and the femininity ratio observed at 55-59 years. Through this index, we then consider the log. Neutralize maternal mortality, young accident mortality, wound mortality, migration, etc. Is a simple way to neutralize these disturbing effects in our analysis. So here we have represented for the age 75, 79, 85, 89, 95, 99, the relationship between cohort fertility and the relative female survival. And as you can see, there is a positive association, and this association becomes stronger and stronger as high age are considered. So here we have also the comparison between the Sardinian situation and Liguria. Liguria is the Italian region with which is supposed to start in Italy before other regions the fertility transitions. So our results highlights two main phenomena. The sex ratio underwent a temporal evolution. A low femininity index at high ages was probably the norm in pre-transitional population. Second, the influence of fertility on the sex ratio becomes strongest with age. At higher ages, let's say between 95 and 99 years, fertility alone can explain about 3/4 of the overall observed variance in the relative female survival. Our analysis, of course, presented a simple correlation, which may be biased by other processes connected to differential survival, such as the general process of mortality decline, the spread of smoking, the obesity pandemics, and so on. To disentangle the effect of fertility from these disturbing factors, we ran 3 checks on the association between fertility and relative female survival. So here, this graph is only to show you that one of the disturbing factors, the smoking mortality, which we assume to be higher among men because of the higher prevalence of smoking among men, was relatively inexistent before the 1875. So the idea is that if we consider very old cohorts, we can assume that these cohorts are not affected by smoking or by the negative effect of obesity. So we restrict our analysis only to the cohorts born in 1862-66 and 1872-76. And what we find is that we still have, at different ages, still a significant effect of fertility on the relative female survival. So this is a first way we have found to take under control the perturbing effect of smoking and the obesity pandemics. Then we repeated this analysis, this time considering the age classes, the cohorts born between 1912, 1916, 1932, 36. These cohorts have been heavily associated to the smoking pandemics. They have been heavily affected by the smoking pandemic. So it is absolutely necessary in this case to introduce a control for smoking, and we do that by introducing in the model the lung cancer mortality separately for males and females. Lung cancer mortality has been measured at the in the age class 75-79. This is a method which has been proposed in the literature to take into account the diffusion of the smoking pandemics, and despite the addition of the regression the regression model of these control variables separately for males and females, the effect of fertility on the relative female survival remains negative also in this, and significant also in this case. Well, the third analysis, the third check of our results concern never married women and older ages. The logic is the following. Being never married is generally considered disadvantageous for female survival in the past. However, if fertility, and this is an hypothesis, is negatively associated to women's post-reproductive survival, the disadvantage of never married women should decrease in the cohorts with higher fertility. Okay, so if we consider being never married in a cohort with a very high fertility, we expect that the disadvantage of being not married is lower. Instead, if we consider the same situation in a condition where fertility is very low, we consider that the disadvantage could be very elevated. This is exactly what we observe in this figure, where the ratio between the proportion of never married women at various old age X and at age 55-59, a measure of the different survival of never versus ever married women in the post-reproductive period, is a regress on cohort fertility. So the analysis of never married women gives another little piece of evidence which support the idea of a relationship between the femininity ratio, the evolution of the femininity ratio and fertility. So the fertility transition appears to have influenced women post-reproductive mortality. The effect of fertility on survival is negative. Lower fertility increases women's survival advantage. The general process of mortality decline and the spreading of smoking have also influenced the evolution of the sex ratio in the post-reproductive ages. The increase in life expectancy has generally negatively influenced the sex ratio. Ceteris paribus, a higher life expectancy entails a reduction in women survival advantage. Smoking, much more frequent among men in the cohort under scrutiny, has increased women survival advantage. Okay, female post-reproductive longevity advantage appears to be connected with the fact that during evolution, a high level of energy reservoir has been devoted for female reproduction, as reproductive costs are higher for female than for males. In this respect, the process of fertility decline seems to represent a major turning point for human biology, because it poses the condition to move energy from reproduction to somatic maintenance, favoring female longevity. This is a famous theory in biology, in evolutionary biology, which is called the disposable soma theory. This theoretical framework seems consistent with our finding, which suggests that in past pre-transitional population, the increased investment in reproductive function compromised somatic investment in health in female, and would explain why the female survival advantage emerges worldwide only in the cohorts born at the end of the 19th century, when fertility starts to decline. let's come back to Sardinia. Well, here, the exceptionally low value of the female-to-male ratio among the older Sardinians seems to depend on past high fertility, because it took Sardinia a very long time to start its fertility transition. Here we have some information derived from the European Fertility Project, and we can see that Sardinia is the, here we have the years. So still in 1950, in 1952, Sardinia was associated with the most elevated index of marital fertility in Italy. Okay, so it's the late comer in the fertility transition in Italy. If we consider the evolution of the fertility transition in the Sardinian province, we see that the Sardinian province is the last province to start the fertility transition in Sardinia. So, consistently with our hypothesis, it was also characterized, the Nuoro province, by the lowest female-to-male ratio ever recorded, 1 male centenarian per 1 female centenarian. So, and this is the conclusion. According to our reconstitution, the high prevalence of centenarian in Sardinia depends on the existence of a specific phase of Sardinian history characterized by a low disease burden and very low nutritional levels. The female population has suffered in Sardinia the disadvantage of a delayed fertility transition process, and this explains why in the IANA analysis of the Sardinian population of centenarian, a very low sex ratio was found among centenarians. Thank you. I've finished my presentation.